there are 3 Newton laws. Okay, I will cover the first law and the second law in this video. The third law will be a separate video because the third law can get kind of confusing. Okay, so let's look at Newton's first law. Okay, Newton's first law states that every object remains in a state of rest or uniform motion in a straight line unless acted upon by the external force. What it basically means is this: if there is no resultant force, Newton's third law is the balance force law. Okay, if the forces are balanced, if there are no resultant force, then this means that if it is stationary, it will remain stationary. If it is already moving, then I will move at exactly the same way, constant motion. Okay, now let's change the word to uniform motion. Okay. So if there is no resultant force, my object, if it is stationary, it will continue to be stationary. If it is already moving, then it will continue to move at exactly the same speed. Okay? And the converse is also true, which means that if my object is stationary and continues to be stationary, it means that there is no resultant force on the object. If my object is moving at constant speed, okay, then it will continue to move at constant speed. Okay, so there is one thing that I want to highlight here. Okay, continue is motion in a straight line. This one, it will appear a lot of time in question as constant speed. Okay, so when you see this word in the question, when you see constant speed in the question, straight away think of Newton's first law, balance forces. No net force, the forces all cancel each other, up equals to down, left equals to right. Okay, constant speed means the forces are balanced. The forces all cancel each other. Okay, so if you see this word, constant speed, uniform motion, constant speed, means that the forces must be balanced. Okay, if the forces are not balanced, point 3, if the forces are not balanced, then I have Newton's second law. Okay, Newton's first law is essentially just this. Okay, if there is no resultant force, it will continue to do what it was doing. If there is resultant force, then I got Newton's second law. What does Newton's second law say? Newton's second law says that the acceleration is proportional to the resultant force and inversely proportional to the mass. Okay, essentially this whole sentence, right, is just a verbal translation of this formula. Okay, the net force, aka resultant force, okay, will be the product of the mass and the acceleration. Okay, so the first law says if there is no resultant force. Okay, second law says that if there is resultant force, the object will accelerate, which means that the object speed will change. Okay, for this, I highly suggest all students to write in the word net here rather than just write F equals to ma, to remind yourself that this formula only works for resultant force. So the net force must be the resultant force. Okay, let me give you an example. Let's say I have a box. This box, the mass is 2 kg. Okay, I push the box with 5 newtons. Okay, and then because I'm pushing it along the ground, there is friction of 2 newtons. Okay, and I want to know what is the acceleration of this box. Okay, so let's say that I want to apply the net force equals to ma. Okay, what is the net force on this object? The net force on this object is actually 3 newtons. Okay, because 5 minus 2, they are acting in opposite directions. So 3 here. Mass is 2 kg. Let me sub in the 2, A, which means that A is 1.5 meter per second squared. Okay, to sub in the net force of 3, okay, I must use this one. I cannot use 2, I cannot use 5. Okay, that is a very, very common mistake. So yeah, just take note of that. Okay, so that is Newton's second law. A lot of the questions on Newton's second law will be asking you to find the net force, use the net force to find acceleration or to find the mass. Or I can give you the acceleration, then I ask you to find one of the forces. Okay.